This is the first lecture of week 10 and we'll discuss panel data. So panel data set is when you have observations on multiple entities, for example, individuals, states, or companies, where each of these entities are observed at 2 or more points in time. So in our previous example, we had 420 California school districts in 1999. So that was what's called cross-sectional data set. If you observe the same set of these 420 California school districts, not only in 1999, but again in 2000, then it would be considered a panel data set. On the other hand, if you had one set of school districts in 1999 and a different set of school districts in 2000, then even though you observe the data in 2 different time periods, because you're observing data for different school districts, it'll be considered cross-sectional. Another example of panel data set is when you have 50 states where each state is observed for 3 years. So you have total of 150 observation, and that would be considered panel data set because you have 3 different years of data points for each state. Let's talk briefly on notation for a panel data set. So in the previous example where we had 420 school districts, we used the notation I to indicate which school district the data point was from. We didn't have a subscript T because everything was from 1999. However, if you have a panel data set, you have 2 different subscripts, I and T, to denote which entity your data point is from or observation is from, and also which year T the observation is from. Another term for the panel data is what's called longitudinal data, and we can use these terms interchangeably. There is a term called balanced panel, and what this means is that there is no missing observations. For example, in our previous case, when we had 420 school districts for years 1999 and 2000, if none of the data was missing, or if none of the observations were missing, then we can say that the panel was balanced. But for some reason, if we had all the 420 school districts in 1999, but we had some of the school districts missing in 2000, then the panel is actually unbalanced. So why are panel data useful? Panel data allows us to control for factors that vary across entities, but that doesn't vary across time. And these factors may cause omitted variable bias if they're excluded from the model. Oftentimes, these factors are unobserved or unmeasurable, so it's hard to include these factors as a regressor in the regression model. So panel data set allows us to control for these factors. The main idea behind the panel data, using panel data, is that if an omitted variable doesn't change over time, then any changes in Y over time cannot be caused by the omitted variable that doesn't change over time. So we'll explore this further in the next several slides. So example that we're going to look at in this section is the data set that includes traffic death and alcohol taxes. So the observational unit is the 48 US states. In other words, the entities are states, and the number of entities in this case are 48. There are 7 years of data from 1982 to 1988, and it's a balanced panel, meaning that there are no missing observations. So we have total of 336 observations. The variables that we have is the traffic fatality rate, which is the number of traffic deaths in the state in that year per 10,000 residents. And we also have a tax on a case of beer, which is going to be our main variable of interest. There are other variables such as legal driving age and drunk driving laws, and so on. Here we're plotting the fatality rate against the beer tax just for the year 1982. As you can see, it looks like there is a slight positive relationship between the fatality rate and beer tax, which is counterintuitive because this is saying that higher alcohol taxes are correlated with more traffic death. And intuitively speaking, we expect the opposite relationship where if you have higher alcohol taxes, people are likely to drink less, which means that the traffic death would decrease. So because what we're seeing is counterintuitive to the economic theory, we suspect that there is an omitted variable bias. So what are some potential factors that affect traffic fatality rate? Some of the examples would be quality or how good the automobiles are, how safe they are, or the quality of roads can also impact the traffic fatality rate. Also, we can think of culture around drinking and driving. So for instance, some states may be more open to the idea of drinking and driving compared to other states which are strictly against it. And then lastly, how many cars there are on the road, how busy the road is can also impact how frequent or how high the traffic fatality rate is. So some of these omitted factors may lead to omitted variable bias. So let's think of an example of traffic density. So traffic density means that there will be more traffic deaths. So in other words, this omitted variable would directly impact Y. Also, the states with higher traffic density can have higher alcohol taxes. So this omitted factor is correlated with the variable of interest. So we can think of states like New York where there's a lot of cars on the road, but the state also has higher alcohol taxes compared to other states. So because of these two conditions of omitted variable bias, we can say that traffic density has been omitted from the regression. So panel data set actually allows us to control for this omitted variable as long as this omitted variable doesn't change over time. And we'll discuss this more in the next lecture.